Welcome to the University of Central Florida Smart and Safe Transportation Lab, where we have developed a real-time data-informed crash prediction and visualization tool based on cutting-edge technologies and artificial intelligence methods that will provide transportation safety insights and life-saving solutions for operators and decision makers. The Smart and Safe Transportation Lab is a group of about 25 researchers from multidisciplinary backgrounds, including transportation engineers, computer scientists, and electrical engineers. These are very ambitious and innovative ideas. We have proven the ideas work and could be used for proactive traffic management to prevent crashes. When we started this work, the data was mostly coming from inductive loop detectors on our roadways. However, the technologies have improved over the years. Those data can be processed and compared with historical data to identify patterns in abnormal situations. Thus, we could predict traffic crashes using real-time data before they happen by about 5 to 10 minutes based on the research that the UCF SST team has been performing in the past decade or so. Therefore, we could intervene proactively using new technologies to prevent crashes or at least reduce their severity.
Section 1. Operators. The first component is for traffic operators, which is password protected. Here is the user interface for operators. The left side window shows different groups of functions for real-time traffic safety management based on multi-source big data from vehicle detectors, connected vehicles, signal controllers, and weather stations. The first function displays the numbers of the high-risk locations in real time, which are identified based on deep learning algorithms developed by the UCF Smart and Safe Transportation team. The high-risk locations are classified into 5 categories for freeways and arterials. Also, the number of high severe crash risk locations is displayed, and the specific locations are visualized by the red jumping icons on the map. The list of the top 3 high-risk locations with the predicted crash risk scores are also provided. Take Freeway Basic Segment as an example. If operators click any of the 3 bars, the map will zoom to the selected high-risk segment. Meanwhile, the real-time crash risk, speed, and volume characteristics of the selected and its adjacent segments could be visualized in the right side window to assist operators to get a better idea about what is happening on the segment. Operators can also select segment directly from the map to get detailed information. Real-time CCTV images are also available for operators to check the field status. Additional data sources could be integrated into the system to conduct further diagnostics, such as videos from UAVs and surveillance cameras. For high-risk locations, proactive traffic management strategies are provided automatically in order to prevent and mitigate potential crashes in real time. These strategies are generated based on previous studies conducted by the UCF SST team, which have been extensively evaluated by simulation and field studies. For example, the system suggests the integrated variable speed limit and queue warning sign for this high-risk segment. To alleviate the crash risk, a queue warning sign is recommended at the end of the queue, and the speed limit of upstream segments should be reduced gradually. To augment the component for operators, the system accesses real-time data from 300 Lynx buses and 50 UCF shuttles. Based on each vehicle's trajectory, 3 types of critical driving events, hard brake, hard acceleration, and the high-speed standard deviation, are generated as safety indicators. The critical events are generated in real time and updated every 60 minutes. Also, more information of each vehicle can be obtained by clicking its own icon. In addition to the current bus or shuttle's data, the system has the capability to integrate other floating cars if data are available. Section 2. Decision makers. Let's move on to the section for decision makers, which is also password protected. The first function shows the dynamic temporal status of the historical safety situation for multiple aspects, including crash frequency, crash risk, and different types of critical events from floating vehicles. The system can summarize the historical PATM recommendation at different time periods. Users can also download historical implementation reports to investigate road safety conditions and schedule their recurrent strategies proactively. For the high-risk locations without PATM devices, an installation recommendation could be provided. The historical events data are saved and displayed in the decision maker part. The crash diagnostics function is based on historical crashes. First, the decision maker can look at macro screening for crash analysis, which is at the zone level. Here, the zones are classified by zip code. Decision makers can check the crash frequency and rate by severity level, and they can see the map on the right side by clicking on the severity level. Meanwhile, decision makers can click each zip code area to see the severity distribution. With the same function, decision makers can also check the violation types. In addition, they can find at-fault drivers' residence. As a result, decision makers can target areas to educate for a particular violation. For example, if they want to reduce the DUI crashes caused by teenagers, decision makers can get the map of those teenagers' residence and overlay it with high schools to educate accordingly. At network level, we provide a decision safety support system. The system offers the most efficient countermeasures and their expected costs and benefits based on the Crash Modification Factors Clearinghouse. According to the recent 3 years crash data, the locations with the most potential for safety improvement are identified and highlighted with the red color. The decision maker can click any of the identified segments to check its suggested countermeasures, which are selected from 6,000 countermeasures for different crash types and facilities. For example, the Decision Safety Support System recommends 2 different countermeasures for this location. Their costs, benefits, and BC ratios are estimated respectively. Besides, for arterials, social media data, including Twitter and Strava, are added. Decision makers can see people's concern about pedestrian safety from Twitter. Meanwhile, Strava data shows bike activities to help improve bike facilities. The last component for decision makers is the CAV component for the county level. Safety improvement by CAV is estimated from our research. For example, if 25% of vehicles are CAVs, it is expected around an 8% crash reduction. Section 3. Public users. Lastly, safety information is available for the public, and it can be accessed by any user. This information pertains to crashes related to pedestrians, cyclists, and violations in their zone. If users click a region, they can see the heat map and severity level. Also, bike lane information can be accessed by cyclists. Additionally, the real-time traffic condition is provided. The locations of schools and hospitals are included for the convenience of the public. The UCF SST team has been a traffic safety pioneer. We have spent over 20 years extensively researching crash occurrence factors and analyzing crash data from many states in the U.S. Based on these efforts, we have developed this visualization tool which uses real-time big data analytics, AI techniques, crowdsourced data analytics, and more. This tool will power road safety management with cutting-edge technologies and provide life-saving insights for each road user. Our system will play an important role in developing safer and smarter cities for the future.